Black holes are cosmic objects of immense density and gravity. Imagine a place where gravity is so strong that nothing, not even light, can escape. That is a black hole, a region of space-time where gravity's pull is inescapable. They are formed when massive stars collapse at the end of their lives. The idea of a place where the laws of physics break down is both fascinating and terrifying. Black holes challenge our understanding of the universe. We can't see them directly because no light escapes. Scientists study their effects on nearby stars and gas. These observations provide clues about the nature of these enigmatic objects. Black holes continue to captivate our imagination, beckoning us to unravel their secrets. The event horizon is the boundary around a black hole. It's the point of no return. Once something crosses the event horizon, it can never escape the black hole's gravitational pull. Imagine a waterfall. The event horizon is like the edge of the falls. Time behaves strangely near a black hole. From an outside observer's perspective, time slows down. If you were to watch a spacecraft fall into a black hole, it would appear to slow down as it approached the event horizon. Eventually, it would seem to freeze in time, never quite reaching the event horizon. However, from the spacecraft's perspective, time would continue normally. The spacecraft would cross the event horizon and fall into the black hole. Spaghettification is a strange and fascinating phenomenon that occurs near black holes. Imagine a spaceship approaching a black hole. The gravitational pull on the spaceship would be much stronger on the side closer to the black hole than on the side farther away. This difference in gravitational force would stretch the spaceship, like dough being stretched to make spaghetti. This stretching effect, known as spaghettification, would become more and more extreme as the spaceship got closer to the black hole. Eventually, the spaceship would be stretched and torn apart, its atoms ripped apart by the intense gravitational forces. Spaghettification is a dramatic illustration of the extreme conditions found near black holes. Section 4. The Unknown, Singularity and the Limits of Physics. At the center of a black hole lies the singularity. The singularity is a point of infinite density. All the matter in a black hole is compressed into this infinitely small point. Our current understanding of physics breaks down at the singularity. We cannot describe or predict what happens at the singularity. The laws of physics as we know them cannot handle the extreme conditions of infinite density and gravity. Some theories suggest that the singularity might be a gateway to other universes. Others propose that it could be a point where space and time cease to exist. The singularity remains one of the most profound mysteries in astrophysics. Section 5. Portals and Possibilities. Wormholes and Parallel Universes. Wormholes and parallel universes are intriguing concepts in theoretical physics. They challenge our understanding of space, time, and reality itself. Wormholes are hypothetical tunnels that connect different points in space-time. These tunnels could, in theory, allow for faster-than-light travel. Imagine folding a piece of paper and poking a hole through it. This simple analogy helps us visualize how a wormhole might work. The hole represents a shortcut between two distant points on the paper. In the same way, a wormhole could create a shortcut through space-time. Similarly, a wormhole could potentially connect distant regions of the universe or even different universes altogether. This opens up fascinating possibilities for exploration. Parallel universes are hypothetical universes that exist alongside our own. They might be very similar to ours, or vastly different. They are thought to be part of a larger multiverse, where an infinite number of universes exist, each with its own set of physical laws and constants. This concept expands our understanding of reality. While these ideas remain speculative, they offer tantalizing glimpses into the vastness and strangeness of the cosmos. The mysteries of wormholes and parallel universes continue to inspire scientists and dreamers alike. Section 6. Unmasking the Invisible. Studying black holes from Earth. Scientists use various methods to study black holes despite their elusive nature. These cosmic giants with their intense gravitational pull are invisible to the naked eye, making them one of the most mysterious phenomena in the universe. One way is by observing the effects of their immense gravity on nearby stars and gas. When a black hole's gravity influences a star, it can cause the star to move in a distinctive way, revealing the black hole's presence. For instance, astronomers can track the movements of stars orbiting a black hole. By carefully monitoring these orbits, they can gather crucial data about the black hole's characteristics. By analyzing these orbits, they can infer the black hole's mass and spin. This information helps scientists understand the black hole's behavior and its impact on the surrounding space. Another method is by detecting the radiation emitted by matter falling into a black hole. As matter spirals into the black hole, it accelerates and heats up, emitting powerful X-rays. As matter spirals into a black hole, it heats up and emits X-rays. These X-rays can be detected by specialized telescopes, providing valuable insights into the black hole's properties. Scientists can study these X-rays to learn about the black hole's properties. This data helps them piece together the puzzle of how black holes form and evolve over time. The Event Horizon Telescope, a global network of telescopes, captured the first ever image of a black hole's shadow in 2019. This monumental achievement marked a significant milestone in astrophysics. This groundbreaking achievement provided direct visual evidence of these enigmatic objects. It opened up new avenues for research and deepened our understanding of the universe's most mysterious entities. Section 7. The Allure of the Unknown, Black Holes and the Future of Discovery. Black holes remain one of the most captivating mysteries in the universe. These enigmatic entities, with their immense gravitational pull, have fascinated scientists and stargazers alike for decades. They challenge our understanding of gravity, space, and time. The very fabric of our universe is questioned when we delve into the study of black holes. The study of black holes pushes the boundaries of human knowledge. It compels us to rethink the laws of physics and explore new theories. It inspires us to ask profound questions about the nature of reality. What lies beyond the event horizon? How do black holes influence the galaxies around them? As we continue to explore the cosmos, black holes will undoubtedly continue to intrigue and inspire us. They are not just objects of scientific study but also sources of wonder and imagination. They serve as a reminder of the vastness of the unknown. The more we learn, the more we realize how much there is yet to discover. The pursuit of understanding these cosmic enigmas will undoubtedly lead to new discoveries and a deeper appreciation for the wonders of the universe. Each revelation brings us closer to comprehending the grand tapestry of existence. The journey to unravel the secrets of black holes is a testament to the power of human curiosity and our relentless quest to comprehend the cosmos and our place within it. This quest drives us forward, ever eager to uncover the mysteries that lie beyond our current understanding. Please like, comment, share, and subscribe for more cosmic discoveries.